now getting into chapter 3. Chapter 3 is more on derivative rules. So you notice a problem on your test was to use the definition of derivative, and I promised you I was going to put one of those problems on there because it's good for the soul and the algebra skills to be able to show, the limit as h approaches 0 of f of x plus h minus f of x all over h, and show that you actually get these derivative rules. So here we go. Let's talk about derivative rules and what you know, because we're going to add to that list today. This section, section 3.1, is on something called the product rule and quotient rule. Right now, the derivative rules, you've got the basic ones, okay? The basic rules are, if y is equal to a constant, then y prime is equal to 0. If y equals a constant times x, y prime, the derivative is just the constant. If y is equal to x to the n, the derivative is going to be n x to the n minus 1. You bring down the exponent, x, and then you subtract 1, and it doesn't matter what the power happens to be. Okay? Unless it's 0, x to the 0 is 1, and then you're back to this rule here. All right? And then we had y equals a constant times f of x. The rule about constants when they're being multiplied is they hold ever. Hold the constant, and you take the derivative of the function. These were your basic rules. But the problem had to look like, and here's an example of one right here, y equals, 3x to the fourth plus 8 square root of x plus 7 over x squared minus 17, x plus 2. All right. My first rule of derivatives is clean it up. I don't like radicals, and I don't like variables in the denominator to have a power. So I clean them up. Y equals 3x to the fourth plus 8x to the 1/2 plus 7x to the negative 2 minus 17x plus 2. Then I take the derivative. What's the derivative of 3x to the fourth? Well, 4 times 3 is 12x cubed plus derivative of 8x to the half. A half times 8 is 4x. To subtract 1, you get negative a half. The derivative of 7x to the negative 2. Negative 2 times 7 is negative 14x, and subtract 1 gives you negative 3. Minus derivative of 17x is 17, and derivative of constant 2 by himself is 0. There's my derivative. Now you can clean them up if you want to, and at this point we're interested in you guys taking derivative. Now cleaning it up will be advantageous later on when we start doing some stuff with this stuff. So if I clean this guy up, we end up getting y prime equals 12x cubed plus 4 over the square root of x. Remember, a negative exponent goes on the bottom, and a half a power was a square root. Minus 14 over, negative exponent goes back on the bottom, x cubed minus 17. The cleaned up version of this guy. Okay? But now, so we're now back into taking derivatives. What are these words that mean derivative? Find the rate of change. Rate of change typically means derivative. Okay? Find the marginal revenue, marginal cost, marginal profit means derivative. Marginal average cost. Take derivative of the average cost function. Okay? If you have distance, the derivative of distance is velocity. So if you're talking about giving you distance and they're talking about velocity, you know to take derivative of this stuff. Okay? Find the slope of the tangent line. That means slope of the tangent line means take derivative and plug in some number to the derivative. See, all these things have this derivative concept that you need to know. But this chapter 3 is about taking the derivative of harder functions. Okay? So the first rule is this. It is called the product rule for this section. Product rule. What if we have a function y equals some function f of x times another function g of x? Straight up f of x times g of x. Okay? The product rule is with sums and differences. Remember, we also had this rule last time. If y equals f of x plus or minus g of x, then y prime was f of x plus or minus g of x. That's how I took the derivative of these guys here. Okay, that works great on f prime of y prime of x, f prime of x plus or minus g prime of x. But to take derivative, you just literally take derivative of each one and just add or subtract them. It doesn't quite work with products. Now in chapter 2, we made you guys FOIL this stuff out, beat up the algebra, clean it up first, and then took its derivative because it ended up looking something like this. But what if you can't, or if the thing is just too big or whatever? What if they start getting more complicated? And I don't want to sit there and FOIL this thing out because the thing's too big to begin with. You can still take the derivative of a product, f of x times g of x, and it ends up being this. The derivative, y prime, would be f prime of x times g of x plus f of x times g prime of x. In these next couple of sections, I'm going to be going over a lot of different rules. And so this f prime g plus f g prime, they're going to get confusing after a while. So that's why I insist that my students not just know the formula. Knowing the formula is awfully helpful, but the words. In my mind, it's math poetry. When I think of product rule, this is what I think of. You take the derivative of the first, and you multiply that times the second, plus you take the first, and then you multiply that times the derivative of the second. That, in English, is the product rule. It's an alternating derivative. You take the derivative of the first times the second plus the first times the derivative of the second. And you'll listen to me, I'm going to beat this into your head until you basically, all through the rest of your life when you're thinking of math and calculus, my voice will pop into your head, okay? Derivative of the first times the second plus the first times the derivative of the second, okay? That is the product rule. So, if I give you an example, y equals 3x squared plus 5x to the 8th minus 2 times 6x plus 7, okay? This is a product. Now, I could, if I really, really, really wanted to, I could fold this thing out and come back in about 3 minutes or 5 minutes or so and combine like terms and get a function that I can get rid of. But that's going to take too long. I want an instant derivative. I want to know what derivative is. I see a product. I see, and here's the word. Stop, pause, hesitate, and listen to what you say. 3x squared plus 4x to the 8th minus 2 times 6x plus 7. That big old times in the middle tells me this is a product. I'm going to use the product rule. Product rule. dy over dx, if you like that Leibniz notation, or y prime is equal to what? Product rule. Derivative of the first times the second plus the first times the second. Half this formula is just recopying this thing down. Derivative of the first. What's derivative of 3x squared? 6x plus what's derivative of 4x to the 8th? Very good. 32x to the 7th. Derivative of minus 2 is 0. That's the derivative of the first guy. Times the second. Just recopy. 6x plus 7. Plus the first guy. Recopy it. 3x squared plus 4x to the 8th minus 2 times the derivative of the second. What's the derivative of 6x plus 7? 6. And here's the beauty of it in this section. I didn't ask you to clean up. This is derivative. Now, if I wanted to clean it up, I could fold this out, distribute the 6, and combine like terms. That's great. But this, honestly, is what I want to see. Because once you start cleaning this stuff up, I don't get to see that, in this case, product rule. The derivative of the first times the second plus the first times the derivative of the second. I don't get to see that action. So I actually want you guys to leave the answer like this for right now. Okay? So I can actually see the derivative of the first times the second plus the first times the derivative of the second. Does that make sense? Okay? So this is the product rule. And there's one other rule for this section, and that is the quotient rule. And I want to compare the two, so I'm going to kind of put it right up here. This one is the quotient rule. Now, quotient is y equals f of x divided by g of x. Instead of multiplication, you have division. To be able to take a derivative of division, this is the rule. Y prime is equal to f prime of x times g of x minus f of x times g prime of x divided by g of x squared. It begins to look a little more complicated, okay? But if you want the version in English, you got it. Here it is. Y prime is equal to, you take the derivative of the top, and you multiply that times the bottom, minus the top times the derivative of the bottom. So you still got this alternating derivative thing here, divided by, and I like to use the word all over the bottom squared. That is the quotient rule. And again, I'm going to drum this into your head because knowing the words is going to be most advantageous. Quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom all of the bottom squared. And the reason why, some teachers in books, you'll see this in a second, like to write it in a different fashion. They'll do bottom times the derivative of the top type thing. It's the same thing, but look at it. Look at the product rule. It's the derivative of the first times the second plus the first times the derivative of the second. Look at the quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom all of the bottom squared. If you look at this numerator, I'm mimicking what the product is except for one difference. Instead of a plus, we have a minus. Instead of first, I'm talking about the top, and the second would literally be quote unquote the bottom. And then you got one other thing, all over the bottom square. This is how you take derivative of these guys. So an example would be y equals 3x squared plus 4x minus 5 divided by 5 square root of x plus 2x minus 1. See, we haven't done a problem like this one before because there's no cleaning this mess up at all. Because it's more than one term. The only quotients we've ever done, I even put one of these guys on the test, was divided by a single term, and you can put it under each term in the numerator. So this one, take derivative. First thing I'm going to do is still John's rule of calculus. Clean it up first. I don't do square roots. So this would be equal to 3x squared plus 4x minus 5 divided by 5x to the 1/2, because I don't do square roots, plus 2x minus 1. So now, take derivative. It's a quotient. Quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Yes, the answer is going to be about yay long when we're done. I know that. That's calculus. But the pattern is simple as long as you got the words memorized. Derivative of the top. What's derivative of the top, guy? What's derivative of 3x squared plus 4x minus 5? Derivative of 3x squared is 6x, plus derivative of 4x is 4, derivative minus 5 is 0. There's derivative of the top. Times the bottom, just recopy it. You can recopy the square root, 5 square root of x plus 2x minus 1. But then it's minus the top, so just recopy the top, 3x squared plus 4x minus 5 times the derivative of the bottom. Now, derivative of 5x to the 1/2, yep, we got fractions. You take a half times 5 makes it 5 halves, x, and subtract 1. 1/2 minus 1 is negative 1/2. Plus derivative of 2x is 2. Derivative minus 1 is 0. So derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom, which is 5x to the 1/2, or square root of x, plus 2x minus 1 squared. And there is my derivative. And yes, it's massive, and they're only going to get worse for you guys, so we're beginning to take derivative of a much harder function. Derivative of the top times the bottom, just recopy it, minus the top, recopy it, times derivative of the bottom, all over the bottom, just recopy it squared. Okay? This is the quotient rule. Because let me tell you where you're going with this stuff. How nasty can they make this mess? They can do combinations. You've got a product in the numerator divided by something in the denominator, so it's a combination of product rules and quotient rules. And you got to pay attention to what part you're taking the derivative of. And you got to figure out who's in command. But once you get the pattern of these rules down, it's going to be long, but it's going to be very direct, and it'll be very much easier once you get the pattern down of this stuff. You're beginning to take the derivative of much harder functions. That's where we're after. So, because let me tell you something, brother. The problem that you're going to be working with in the future of financing and stuff is not going to look like 3x squared plus 2x minus 5. It's going to be a lot nastier than that in terms of analyzing what's exactly going on with input is the number of units I'm trying to sell, output is profit or cost or whatever. These equations can get rather interesting. And you've got to be able to take derivative of those things to figure out these marginal rates and stuff. Okay? So, come over here and take a look at our notes here for this section. All right, so let me blow this up. So again, we're going to take derivative of much harder stuff. So here we go. If f of x and g of x are differentiable functions, and y equals f of x times g of x, then dy over dx, and that's our Leibniz notation for the derivative, is going to be f prime of x times g of x, because it's a product, plus f of x times g prime of x. It's an alternating derivative. Derivative the first times the second plus the first times derivative the second. Okay? And I tried to put this in the notes here. Okay? So the derivative of the product rule of the two functions is equal to the blank function times the derivative of the blank. So this one they do the second function times the derivative of the first function. Okay. He takes us the second function times the derivative of the first function plus the first function times the derivative of the second function. And it's their way of writing out. It's derivative the first times the second plus the first times derivative the second. Just trying to write it out for you guys. That's what you could need to have memorized. Okay? However, look at number 3 here. Again, throwing these guys at you at one time. If f of x and g of x are differentiable and y equals f of x divided by g of x, then dy over dx, our Leibniz notation for the derivative, is going to be f prime of x times g of x, what? Minus f of x times g prime of x all over g of x squared. Okay? So, the derivative of quotient is the blank times the derivative of the blank. Well, it is the denominator. I'm going to put bottom. It is the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the square of the bottom. Now, I'm using my shorthand notation because I'm trying to drum these words in your head. The official notes, if I wanted to write it up officially, they would have said, when you're talking about quotient, you got a numerator, denominator. The derivative of the quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. It gets kind of long here. I'm trying to get this stuff in your head. So here's my words. Quotient rules. Derivative of the top times the bottom minus the top times the derivative of the bottom, all of the bottom squared. That's much easier for folks to memorize, and that's what I'm after. Making sure you know how to take the derivative of a large quotient. Okay? So, in the wonderful www.hawkstv.com, they actually work a problem very similar to this one. So please watch it and maybe take notes off of that as well. All right, so now this one, all right, I'll be the first to admit to you, I wouldn't write it like this. It says, use the product rule to find the derivative of f of x equals 2x to the negative 3 plus 1 times negative 4x cubed minus 3. Okay, great. Fact is, when I give you a test question, all I'm going to do is say, take the derivative of this guy. What do you see here? This is what I want you guys to recognize. I see 2x to the negative 3 plus 1 times negative 4x cubed minus 3. Big times in the middle tells me this is a product. I'm going to use the product rule. So here we go. So f prime of x, and even though these formulas are great, the words are much more powerful. Product rule. Derivative the first times the second plus the first times derivative the second. Derivative the first. What's derivative of 2x to the negative 3 plus 1? Well, negative 6x to the subtract 1, negative 4. That's derivative of 1 is 0. That is the derivative of the first. Times the second, recopy it. Negative 4x to the 3 minus 3. Derivative of the first times the second plus the first. Just recopy it. 2x to the negative 3 plus 1 times the derivative of the second. What is the derivative of negative 4x cubed minus 3? Negative 12x squared. All right, go do it. And that's really what we want. And I'm going to actually tell you guys on a test, as awesome as this is, take the derivative and don't clean it up. Okay? The reason why I'm going to ask you not to clean it up is because I'm trying to basically grade your ability to take derivatives. And once you do this, I can see derivative first term second plus first term to the second. I know you got it right. Now, if I clean this guy up, which you're going to have to in your future here, I'm going to distribute this. Negative 6x to the negative 4 times a negative 4x cubed. Negative 6 times a negative 4 is what? 24. X, when you multiply, multiply x to negative 4 times x to negative 3, you add exponents. That'll be what? X to the negative 1. And then negative 6x to negative 4 times a negative 3 becomes plus 18x to the negative 4. Just multiply the constants and leave that x to negative 4. Plus, here I'm going to distribute 12x to the negative 3 times a negative 2. 2x to the negative 3 times a negative 12x squared. Well, 2 times a negative 12 becomes an actual minus 24x. X to the negative 3 times an x squared is x to the negative 1. Okay? And then plus 1 times minus 12x squared will be minus 12x squared. Okay? So when I'm cleaning this guy up, what do you happen to notice? Now, plus a negative is a minus. Okay, great. But that 24x to negative 1 minus 24x to negative 1 ends up wonderfully canceling. And I end up getting f prime of x being equal to negative 12x squared plus 18x to the negative 4. There's the cleaned up version of it. But I'm telling you right now, going to have to do this because we're going to apply this calculus later on. But right now in chapter 3, I'm just going to ask you guys to take derivative and not clean it up. And honestly, even if you put this into your homework Hawk system stuff and not cleaned up, it'll kind of write. Does that make sense? Look next guy here. All right. Use the quotient rule like you've got an option here. I've taken derivative of this. F of x is equal to 2x to the 1/2 minus 4x to the 3/4 divided by 2x squared plus 1. That big old divide by means it's a quotient. It means I got to use the quotient rule. So let's go through it again, drilling it in your head. Quotient rule. Drill the top times the bottom minus the top times drill the bottom all over the bottom squared. Things are going to be large when you're done with taking derivative of quotient. Drill the top. Here we go. Drill the top. What's derivative 2x to the half? A half times 2 is 1. X and subtract 1 will give you negative 1/2. Minus, what's derivative of 4x to the 3/4? Well, 3/4 times negative 4 would be minus 3, because the 4's end up canceling. X and subtracting 1, 3/4 minus 1 is a negative 1/4. That is the derivative of the top. Times the bottom, just recopy. 2x squared plus 1. Minus the top, recopy. 2x to the 1/2 minus 4x to the 3/4 times the derivative of the bottom. What's the derivative of 2x squared plus 1? 4x. Derivative plus 1 is 0. All over, don't forget this guy, the bottom, 2x squared plus 1 squared. All over the bottom squared. Now, if I ask you guys to clean it up, you would actually end up having to FOIL this part out and distribute this guy and distribute the negative and then combine like terms. Okay? And we could do that. Let's do that because it's good algebra practice. Here, x to the negative 1/2 times 2x squared. When you multiply, you add exponents. That would be 2x to the minus 1/2 plus 2 is 1.5 or 3/2. Okay? And then x to the negative 1/2 times 1 is plus x to the negative 1/2. Minus 3x to the negative 1/4 times 2x squared. Minus 3 times 2 is a minus 6. X to the negative 1/4 times an x squared. And when you multiply, add exponents. Negative 1/4 plus 2 is 1 3/4, which is 7/4. Okay, and then last, of course, negative 3x to the 1/4 times 1 is negative 3x to the negative 1/4. Minus, I'm going to distribute the 4x. 4x times 2x to the half. 4 times 2 is 8x. X to the 1/2 times x is x to the 3/2. And then a 4x times a 4x to the 3/4, so it'll be minus 16x. X times x to the 3/4, so it'll be x to the first. We multiply x, add exponents. That's 1 3/4, which is 7/4. All over the bottom squared. Well, I'm not done cleaning it up yet because that negative is going to distribute. So f prime of x would be equal to 2x to the 3/2 plus x to the negative 1/2 minus 6x to the 7/4 minus 3x to the negative 1/4. The negative distributes minus 8x to the 3/2 plus 16x to the 7/4 all over 2x squared plus 1 squared. And then the last thing I'm going to do is combine like terms. All right, let's see what we got here. I got a 2x to the 3/2. I got a minus 8x to the 3/2. As long as the variables are identical, you just add their coefficients. What is 2x to the 3/2 minus 8x to the 3/2? Negative 6x to the 3/2. And I always draw a little line to them, let them know I'm done with those two terms. Okay? All right, I've got here plus x to the negative 1/2, and I don't see any other x to the 1/2, so that's good, negative 1/2. I got a minus 6x to the 7/4, and I got a plus 16x to the 7/4. Well, they're the same variables, so how much do I have? Plus 10x to the 7/4. I'm done with those guys. And then I got a minus 3x to the negative 1/4, only one looking like that, all over my bottom, 2x squared plus 1 squared, and there is my result. Does that make sense? There's my derivative. And then if I ask you some weird question like, what is the rate of change of this function at x equals 1, what are you going to do? Plug in 1 and all these guys and crunch out a number. What is the marginal whatever of this particular function? Well, at x equals 2, I'm just going to plug 2 into my derivative. Okay? Get these words down in terms of when to take derivative. Okay? On this one, it says use the product rule or quotient rule to find the derivative of the following. All right. They want you to practice the quotient rule, but honestly, if you gave me this problem, I wouldn't have done the quotient rule or the product rule. I would have cleaned it up first. You'll get the exact same answer. Let me show you. Okay, here we're going to do the derivative. And I see x squared times 1 plus 3x minus 2x squared. It's a product. I'm going to use the product rule. Derivative the first. Derivative of x squared is 2x times the second. 1 plus 3x minus 2x squared. Derivative the first times the second plus the first, which is x squared times derivative of the second. Derivative of 1 is 0. Derivative of 3x is 3. Derivative of minus 2x squared would be minus 4x. Does that make sense? There's your answer, and that's the product rule. But let's clean it up. So my derivative would be equal to, I'm going to distribute here, that would give me 2x plus 6x squared minus 4x cubed, plus I'm going to distribute the x squared plus 3x squared minus 4x cubed, and then I'm going to combine like terms. Okay, I've got a 2x, I've got an x squared, I got a 6x squared plus a 3x squared. How much do I have? Plus 9x squared, and then I got a minus 4x cubed minus another 4x cubed. How much do I have? What's minus 4x cubed minus 4x cubed? Minus 8x cubed. And there's my result. However, honestly, this would have been John's way. If I was really going to do this problem, I'm going to do real math here. Clean it up first. Why? I mean, granted, we're practicing quotient rules and product rules and the like, so they're making me do this stuff because I'm trying to practice. But if I was going to do this problem, you know what I would have done? Clean it up first. Clean up first. I would distribute. So f of x would be equal to, what's x squared times 1 is x squared. What's x squared times 3x? It would be 3x cubed. And x squared times minus 2x squared would be minus 4x to the 4th. When you multiply, you add exponents. Now take derivative. Knock yourself out. What's derivative of x squared? 2x. Plus what's derivative of 3x cubed? 9x squared. What's derivative of minus 4x to the 4th? Minus 8x, subtract 1 cubed. There's my answer. Now I ask you, which one was easier? Cleaning it up first. Always is easier. But they put a gun to my head and said, hey, use the product rule. Okay, fine. Oh, I did it that way too. I ended up getting the exact same answer. okay? Because you guys have to be really good at math. But notice, this is the beauty of math. There may be more than one way to do something or other, but there's only one answer. That's why we love math, okay? So I could have cleaned it up first or done the product rule and cleaned it up last. Cleaning up last made me do more work and stuff like that. Yeah, question? Yeah. 4 times, let's see here. Hold on. I screwed up. It's my fault. X squared times a minus 2x squared will be a minus 2. See, I had that answer already in my head. X squared times a minus 2x squared is a minus 2x to the 4th. Now, take your derivative. What is 4 times 2? Yeah, there's only one answer. I knew what the answer was before I started, but I just screwed up that. That's 2x squared times a minus 2x squared is actually minus 2x to the 4th. And then I took the derivative. You gotta watch me. I'm already got 14 steps ahead of you guys, and I forgot what I'm actually working on. Does that make sense, though? So my point is, you can either clean it up later or clean it up now. Clean it up now is always makes your problem shorter. All right, take a look at this next problem. Okay? G of x is equal to 3x squared minus 8 times x squared plus x. We're going to be using the product rule or the quotient rule, and I'm not going to clean them up because I want you guys to see the rules in action. That's really what this section is all about. So here we go. G prime of x, this is a product. 3x squared minus 8 times x squared plus 1. So we use the product rule. Product rule, derivative of the first, derivative of 3x squared minus 8 is 6x. Derivative of the first times the second, x squared plus x. Plus the first, 3x squared minus 8 times derivative of the second. Derivative of x squared minus x squared plus x is going to be 2x plus 1. Derivative of the first times the second plus the first times derivative of the second. However, and I'm going to leave it like this and not clean up my answer because this is the way I want you guys to see this stuff because I want to see the actual rules in action. But look at the next one. F of t is equal to 1 minus 3 over t squared times 2t squared plus t minus 1. Even with these kind of problems, and I'm going to use the product rule again because it's a product, we're multiplying, I got to clean up my little individual guys. I don't do stuff on the bottom and I don't do radicals. So I haven't taken derivative yet. F of t would be equal to 1 minus 3t to the negative 2 times 2t squared plus t minus 1. And now, take derivative. Product rule, derivative of the first times the second plus the first times derivative of the second. Derivative of the first, derivative of 1 is 0, derivative of minus 3t to the negative 2. Negative 2 times negative 3 is a positive 6t to the subtract 1, negative 3. That's derivative of the first times the second, just recopy it. 2t squared plus t minus 1 plus the first, just recopy it. 1 minus 3t to the negative 2 times the derivative of the second. Derivative of 2t squared plus t minus 1 is going to be 4t plus 1. And there is my quote. Product rule. But I still had to do a little bit of this cleanup stuff. But now, look at the next one. Y equals 2x squared plus 3x divided by x cubed plus 6. That big divide right in the middle of this thing means this problem is a quotient. Quotient rule. This is what take command, that big divide in the middle there. Quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom, all over the bottom squared. So here's my y prime, or if you like Knicks fans, dy over dx. Quotient rule, derivative of the top. Just recap, what's derivative of the top? 2x squared plus 3x. That would be what? 4x plus 3. Derivative of the top times the bottom, recopy, x cubed plus 6. Minus the top, 2x squared plus 3x. Notice these parentheses around these functions are very important. Times the derivative of the bottom. Derivative of x cubed plus 6 is 3x squared all over, big divide, the bottom, x cubed plus 6 squared. And there's my answer. And this is what I want to see. I will get you guys to clean it up later so we can set them equal to 0 and stuff. That's great. But not right now. We're learning the rules. Does that make sense? Look at the next one. G of x equals 6 times the square root of x divided by 3x minus 4. First thing I'm going to do is one identify. It's a big old divide here, so it's a quotient rule. But I don't do square roots. I'm going to clean them up first. This is 6x to 1/2 divided by 3x minus 4. So now labeling is everything in calculus. If these guys have names, the derivatives have names. This function was called g of x, therefore the derivative is called g prime of x, or dg over dx if you like the Latin stuff. Quotient rule, derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. Derivative of the top, derivative of 6x to the 1/2, 1/2 times 6 is 3x, and subtract 1 is negative 1/2. Derivative of the top, times the bottom, recopy, 3x minus 4, minus the top, 6x to the 1/2, times derivative of the bottom. What's derivative of 3x minus 4? 3, all over the bottom, 3x minus 4 squared. There's my answer. Does that make sense? And again, we can clean them up, but I actually want to see this. And if you type this into your Holt's homework set, basically you got the little template there, but don't forget to put parentheses around each term that you're doing. That's very important, because that negative is going to distribute. F of x and g of x are differentiable functions. And they're trying to throw, this is how they like to give this game. So this is a game now. F of 2 equals 3, f prime of 2 equals negative 1, g of 2 equals negative 11, and g prime of 2 equals 6. Find the value of h prime of 2 in each of the following. All right, look at this problem here. H of x equals f of x divided by 2x plus 1. That is a quotient. So to take the derivative, I've got to use the quotient rule. Quotient rule, derivative of the top times the bottom minus the top times derivative of the bottom, all over the bottom squared. Derivative of the top, derivative of f of x is going to be f prime of x. Derivative of the top times the bottom, copy, 2x plus 1. Minus the top, f of x, times derivative of the bottom. Derivative of 2x plus 1 is 2, all over the bottom, which is at 2x plus 1 squared. That, using the rules, and the derivative of f is going to be f prime. This is what you get with the quotient rule. Does that make sense? Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. But they want me to find h prime of 2. So h prime of 2 would be equal to f prime of 2 times 2 plus 1 minus f of 2 times 2 all over 2 times 2 plus 1 squared. Now I'm going to plug it in. What's f prime of 2? They gave me that one. F prime of 2 was negative 1. That'll be negative 1. What is 2 times 2 plus 1? 2 times 2 is 4, plus 1 is 5. Okay, I'm just crunching my numbers here. Minus f of 2, they gave me that. F of 2 was equal to 3 times 2 all over 2 times 2, which is 4 plus 1 is 5 squared. So I'm going to clean this guy up. Negative 1 times 5 is negative 5. Minus 3 times 2 is 6 over 5 squared is 25. Minus 5 minus 6 is minus 11 over 25. And that is the solution. Does that make sense? One more, then I'll let you guys go. Try this one here. H of x is equal to f of x times g of x. Right? That is times, which means what rule am I going to use? Product rule. And this is just, you can memorize the formula, and that's awesome, but know the rule. It's a product rule. F of x is first, g of x is second. Product rule. Derivative the first times the second plus the first times derivative the second. Derivative first. Derivative of f of x is going to be f prime of x times the second, g of x. Plus the first, f of x, times derivative the second, g prime of x. But again, they want me to find h prime of 2, so I'm going to replace all the x's with 2. That would be f prime of 2 times g of 2 plus f of 2 times g prime of 2. Now, I'm going to go back up here and look at what they gave me. So h prime of 2 would be equal to f prime of 2 was negative 1 times g of 2. G of 2 is negative 11 plus f of 2, which is 3, times g prime of 2, which is 6. So when I clean this up, negative 1 times negative 11 is positive 11, plus 3 times 6 is 18, and 11 plus 18 is what? 29. And there's my answer. But look at the next one. We'll do this one next time, but I just want to take 30 seconds to look at it. Find the equation of the tangent line of the function and look at it. It's x to the fifth minus 5 times x cubed minus x minus 1 at the point 0, 5. Same problem that was on your test, except the function is now bigger. Anytime I want to find the equation of a line, especially a tangent line, I could use the point slope formula. They gave me the point. I just got to find the slope of the tangent line, which means I'm going to take its derivative and plug in x is 0, crunch that number out, and finish it up. We'll do that problem next time. It's a great problem to practice with. But go ahead and start getting certified on this particular section, and we're going to move into the chain rule next time. So see you guys then.